Hello, this is the section 3.1b lesson. In part A of this lesson, we talked about using simple strip diagrams to solve word problems. In this section, we're going to talk about a little more complicated problems that we can solve with strip diagrams. So when we use strip diagrams to solve these problems, we're not going to be doing a lot of arithmetic. Instead, we're going to draw pictures that captures the relationship between the numbers, and then we're going to use reasoning to figure out what the answer is. So let's start off with a very simple word problem here. So Wilma saved $184. Wilma saved $63 more than Betty. How much did Betty save? So our unknown quantity here is the amount that Betty saved. And so let's draw a little strip here to represent the amount that Betty saved. We don't know what that is, how much that is, so we're going to put a question mark there. But we're told that Wilma saved $63 more than Betty. And so let's add a little extra strip on there. And this is this additional $63 that Wilma saved. But then we're told that overall, Wilma saved $184. And so that picture illustrates this relationship between these numbers in the problem, the number 184 and the number 63, and then this unknown quantity as well. And so from this picture we can see that the unknown quantity is going to equal the 184 minus 63, and then if we do that simple arithmetic we get 121. And so there's our answer. The unknown quantity, which is the amount that Betty saved, is $121. Alright, so that first word problem was very simple. Let's look at something a little more complicated. It says Michaela and Sally have 2,000 stickers altogether. If Michaela had 600 more stickers than Sally, how many stickers does Michaela have? Right? So we've got a lot of things going on here. Michaela and Sally both have stickers. We don't know how many they each have. Told they have 2,000 altogether, and Michaela has 600 more than Sally. And so let's start off with, let's draw a picture of Sally's. There's lots of different ways we could draw this, but here's one way. Okay, so this strip here represents the amount that Sally has, and we don't know how many that is. But then Michaela, we're told that she has 600 more than Sally. So Michaela has this same number here, which we don't know, but then she has an additional 600 stickers. Okay. And we're also told that altogether, if we put all these stickers together, we have 2,000. Okay. Well, let's make an observation here. We know this amount, we know that these two amounts are the same, and so if we take the 600 away from the 2,000, what we have left is just the amount right here, and that's going to equal 1,400. Right? 2,000 minus 600 is 1,400. And so from there we see that these two strips together, which are the same amount, we don't know. We know if we add them together we get 1,400. So I think of what number plus itself is going to equal 1,400. Well, that's going to be 700. So question mark is equal to 700. And so now we know what this quantity is right here. We want to know how many stickers does Michaela have. So Michaela is going to have the 700 here plus the 600. And so then, let's use black here. So Michaela is going to have 700 plus 600. And if we do that simple arithmetic, we get 1,300. So there's the number of stickers that Michaela has. Now Sally, it doesn't ask how many stickers does Sally have, but we can see that Sally is going to have 700 stickers. So there we go. We drew some simple strip diagrams that illustrates the relationships between these numbers, these known numbers and these unknown numbers, and we reasoned through it to figure out our answer. That's how we use strip diagrams to solve word problems like this. Here's another one that looks a little bit different. Rainey had $47 after paying for 3 kilograms of prawns. Prawns are kind of like, I don't know, crawdads of some sort, or shrimp maybe. Rainey had $20 left. Find the cost of 1 kilogram of prawns. Okay, so there's a lot going on here. We had $47, we bought 3 kilograms of prawns, and then we had $20 left. Find the cost of 1 kilogram of prawns. Well, let's start off by drawing a big long strip here to represent the $47 that he had. Okay. And now it says that he paid for 3 kilograms of prawns, and then he had $20 left. Okay. So maybe let's draw a little strip here to represent the $20 that was left. And so that means that he had to pay $27 for the prawns. But now the question is, well, how much does 1 kilogram of prawns weigh? Well, let's take this strip that represents $27 right here, and let's divide that up into 3 equal pieces, like this right here. So that means that each one of these pieces represents the cost of 1 kilogram of prawns. So if we take 1 kilogram plus a second kilogram plus a third kilogram, we should get $27. So what number plus itself is going to give us 27? Well, the answer is 9. 9 plus 9 plus 9 is equal to 27. And so each one of these pieces here represents 1 kilogram of prawns. It also represents $9. And so 1 kilogram of prawns is going to equal $9. There's our answer. So again, we see how we're using strip diagrams to represent, to illustrate the relationship between these numbers, and then we use reasoning to figure out what the answer is. So our last example is going to involve fractions. Now, don't let fractions scare you. In order to solve this problem, we're going to go back to the meaning of fractions. So it says 3/7 of the apples in a box are red apples. The rest are green apples. There are 24 green apples. How many apples are there altogether in this box of apples? And so it says we've got 3/7 of the apples in a box are red apples. So let's draw a strip here to represent our box of apples. Now we don't know how many apples are in this box. That's what we want to figure out. So it says 3/7 are red apples. So 3/7, what does that mean? That means that we're going to take our whole, and our whole here is the apples in this box. We're going to take that whole, divide it up into 7 pieces, and we're going to select 3 of those pieces. So divide it in 7 pieces, we're going to draw 6 vertical lines. 1, 2, 3, 4, 5, 6. So each one of these 7 pieces represents a group of apples. Maybe it's better to think about these as groups rather than pieces, because we're not cutting up an apple into pieces. Really, we're taking our box here and dividing it up into different groups of apples. Now each one of these groups has the same number of apples in it. Now we don't know how many apples are in each one of those groups, but we do know that each one of those groups has the same number of apples, even though this group here looks a little bigger. It's all the same size. So 3/7 means we're going to select 3 of those pieces. So let's shade 3 of those pieces. And so those 3 pieces are going to be our red apples. Now it says the rest are green apples. And so here we've got these last 4 groups are green apples. Now we're told that there are 24 green apples. So if we take this group plus this group plus this group plus this group, we should get 24. Each one of those groups has the same number. So I think what number plus itself plus itself plus itself is going to equal 24? Well, the answer is 6. 6 plus 6 plus 6 plus 6 is equal to 24. So that means that each one of those groups contains 6 apples. Now remember, all of these groups are the same size. So if these groups over here contain 6 apples, then that means that these groups over here also contain 6 apples. And so from there we see that there are total of red, we've got 6 plus 6 plus 6, which is 18. The green apples, we've got 24, we already told that, and so that means total we have, 18 plus 24, and we do that arithmetic and we get 42. So there's our answer. We have 42 apples in our box. So again, you see how we went back to the definitions of, in this case, of fractions, and we use this relationship between all these numbers and this picture to figure out the answer. So that's it for this lesson. Now we already read section 3.1, so there's nothing more to read before class next time. So in class next time we are going to practice using strip diagrams to solve some word problems very similar to the ones that we just did.